Hello friends, welcome back to my channel, and today we are going to talk about one interesting and little bit different topic which is off topic, and it is going to be a bit of a theoretical one, but it is going to help in long term in AI and in LLM perspective. So let's get started. So LLM is a costly business in terms of whatever we want to ask to or raise a query to LLM, it is going to respond. Now, in commercial application, there is a cost involved. There is a tokenization involved, and there is a time involved in it. So how can we optimize it? How can we save cost and how can we save time? So the major part is going to be tokens. So if you save more tokens, then effectively it will save time and cost. So there are a couple of ways I have put down together. So let's get started. Let's discuss on that. So keep calm and token on, right? So the first and major part is monitor and analyze token usage. So there are a couple of points here. So log token usage per request, specify output format clearly, monitor cost per feature, and use dashboards for monitoring. So let's see this. So I have this portal which will actually calculate the tokens required for typical AI model. So let's see in detail. So I have a simple prompt or simple query. What is the capital of France? So for Google Gemini, typically, again, this is not an exact calculation, but it's a tentative calculation. So Google Gemini takes 8 tokens, then OpenAI or ChatGPT will take 7 tokens. Okay. And let's take this cloud. This will take, okay. So let's proceed for the next one until we get this. I have a different one more prompt which is a bit lengthy. This will make me a diet plan for summer for age from 18 to 25. So Gemini is taking 20 tokens and ChatGPT is taking, it is also giving the breakup also. It is taking 16 tokens, and this, let's take this Grok. So Grok is taking 16 tokens. So if you see, typically this Google Gemini is 20 tokens and ChatGPT is 16 tokens. So if it is a small prompt, then it's okay. But if it is a bigger prompt, let's say 100 words, 500 words, or maybe 2000 words, then it really makes a difference. Okay, now let's take one more. So book me cheapest tickets for Christmas from London to Paris. So Gemini is 15 tokens, ChatGPT is 14 tokens, so 1 token less. Okay, and for cloud, okay, it is calculating. So let's take the first one. So it is still calculating for the cloud, but that is fine. So we came to know, okay, there are some token involved, and this is one website. Simply we can go and check the token. Okay, just for the sake, I will take this as a prompt. Okay, and because it's a bigger prompt, so I will paste it here. Let's go to Gemini. So Gemini is taking 114 and OpenAI is taking 112. So plus or minus maybe here and there, but it is almost similar, right? So let's see further. So so these are the steps we need to consciously follow so that it will save time and cost. So log token usage per request. Okay, so once every hour, every day, or every week, we will have a data of the token usage, and then we can see, okay, what are the queries which can be optimized or which can be rethought so that we can save token. Okay, this will also act as a dashboard. Identify high token consuming prompts. Okay, so typically what happens is when you give a text based text prompt, then it will calculate the text, but then when you attach a file, so there is additional steps involved to download the attachment file internally on the server and then see what are the contents, how many pages, or in case of Excel, how many sheets, and are there any which language it is, and so on. So there is an additional step involved which will consume your tokens. So that is why if you want, you can avoid having attachments. Set token limit in API configuration. Yes, in the API what we are calling. So typically for commercial applications, this querying the LLM will be using API. So we can have a hard limit on the API about the number of tokens per API. Analyze repeated prompts, use caching. Okay, bit improvement. So let's say some of the information is typically asked again and again. Let's say there is a, Christmas day, there is a sale going on. So many of the people, many of the users will be asking some questions related to the sale. So then you can use something from the cache, which will also save time and cost. Um, Use dashboards for monitoring. Yes, okay. So we can see dashboard kind of thing. There are different dashboards. OpenAI uses dashboard, custom Grafana, and those things that we can build, and there we can monitor at a visual level. Okay, moving on. So demo. Yes, we have seen the demo on this website. So we have seen a demo. Next is choose the right model. Okay, so LLM, again, LLM is having n number of models, AI models in backend, and then we have to choose wisely. Use a smaller model for simple steps. Use large model only for complex reasoning. Use fast models for high volume application. Use embedding model for search and node generation. Okay, use tiered architecture and use code optimized models for coding tasks. So there are different expertise available for different types of LLM, and then we have to use them accordingly. Yes, smaller model for simple tasks. Okay, so small requirement. Let's say it's an addition or mathematical thing or very simple thing, just to add some string or numbers. So then we can go for the simple models. Okay, large model for complex reasoning. Let's say we want to analyze some stock market performance. So there is a lot of things are involved here. So for large model, large queries or the complex reasoning, you have to use large model. Embedding for model for search and node generation. So embedding is one of the step, which we can embed some particular additional info for a particular chunk of data. And it will be useful for searching. So that is why we have to use different model. For fast model, for high volume application, yes, use fast model, which will do your operation very quickly, and will suffice the purpose instead of using LLM everywhere. Use code optimized model for coding tasks. Okay, so we have different LLM for coding related thing, which is not basically something like a reasoning or embedding or smaller tasks. So we have to write some code. We have to provide some code, let's say Python code or Java code or JavaScript code or whatever. So for that, we have special LLMs available. So choose the right model. Use a tiered architecture. So small model for classifying the request, large model handle complex requests, and so on. Okay, so tiered architecture. Right. Now moving on. Use RAG. Use retrieval augmented generation. So LLM and RAG both are kind of doing the same thing, but with a different approach. So LLM is basically process intensive. It will think in multiple direction. But in RAG, which sometimes uses the LLM in backend, but it is very fine tuned, very structural approach. So send only relevant data instead of full database. Okay, store documents in vector database. So it is doing additional steps. Retrieve top k relevant results. So let's say there are LLM has provided 10 or 15 results for your particular query. So RAG, using RAG, we can have top 3, top 4 results, which are sufficient for 90% of the work. Use summarized chunks. Okay, use metadata filtering and chunk documents intelligently. Right. Send only relevant data instead of full database. Okay, so again, it's an optimization. When we send a query to RAG, store documents in vector database. So this is basically some kind of a um, uh, pre-decided format or indexed format or a known format to store the data in the database. So it is easy to retrieve, because if you give it to LLM will have a lot of combinations and lot of processing involved. But in terms of RAG, it will be a bit easy. It will be less costly or less time consuming. Uh, Chunk documents intelligently. Yes, whenever we break a given document or given data in chunks, then we have to chunk them intelligently. So we have different chunking methods, semantic chunking, and many other chunkings are there. So so what will happen is this will increase the cost at the first time, but then for all the rest of the period, it will give the proper information from proper chunks, and that is going to help, let's say, 90% of the time, 95% of the time. Yes, retrieve top K relevant results. Okay, so if you want to, let's say, analyze some stock markets, obviously we don't want to have analysis for the food or something which is not relevant. So the point is, top K relevant results are useful. So that is done by the RAG. Use metadata filtering. So whenever we kind of related to database, so whenever we chunk the input data and we store it, we store it some in some database and you add some metadata. So if there are 10 chunks and out of 10 chunks, there are two chunks which are related to finance, three chunks which are related to sports, and remaining are related to some stock market. So when we retrieve by the metadata, and that is going to help reduce the retrieval time. Okay, use summarized chunks instead of raw chunks. Okay, so we can have a summary, short summary. Let's say if there is a paragraph we want to store, instead of that paragraph we can store a summary within two sentence or one sentence with maximum 15 words, so something like this. So that will again help to increase to lower the cost and time. Okay, optimize prompt engineering. So use precise instruction, specify output format clearly, use reusable prompt templates, avoid redundant context. Okay, so optimize your prompt engineering. So whatever prompt we are giving to the LLM, that is also one of the item to improve on. So use precise instruction instead of open-ended prompts. Okay, so here, for example, explain software testing. Okay, or explain LLM. So this is an open-ended question, and LLM, will go on in recursive thinking mode, and then it might, take a lot of time, or it might give you some answer which is not specific to what you want, or it might give you a very generic answer. So instead of that, precise instructions. So explain API in software testing in 5 bullet points with one example under 150 words. So if you see, very very precise instructions are given, and then we will have a precise result. Okay, so that is, it will reduce unnecessary verbosity and token consumption. Right, so it's a win-win. We want to save token, we want to also have the correct targeted question so that we'll get the similar answer. Okay, now specify output format. Yes, instead of having a text, sometimes we want it in some different format: Excel, CSV, JSON, um, Word, PPT, slide, image, whatever. So specify exactly what you want the format. uh, Avoid redundant context. Okay, so obviously when we want to query about, let's say, diet or health related, so we don't want to get into something which is not related to health. Okay, so redundant content to be avoided, context to be avoided. Use a system style constraints inside a prompt. Okay, so basically we are giving step by step instructions. So if instead of just asking a question, we can say, okay, act as a this person. I want act response to be in XYZ words, no introduction, no conclusion, and something. Okay, so basically a style constraint inside a prompt. So if you have this uh, kind of query mechanism, then it is very easy to give you the required answer by the LLM. Okay, break complex tasks into smaller prompts. This is very much needed, because if you just say, I want to write a program on with Python to open a browser and close the browser and automate some website, instead of that, break it down into 10 steps, and then give the 10 steps as a small a breakup. So that will ease your expected output. Use reusable prompts. Okay, same thing as I mentioned here, reusable prompts. So RTF, request task format, or row days, or care, and there are many, as per the domain of question, there are many templates which you can find online, and in that format only you raise a query. Okay, right. Manage context window wisely. Okay, so remove irrelevant conversation history, use summarization for long content, avoid repeated system instruction, trim unnecessary output, use short identifiers instead of full data, store important information externally. Okay, so let's see this in detail. Remove irrelevant conversation history. Yes, we uh, let's say we want to query to your AI model. Okay, so we are asking, let's say, one question, two question about a topic. Okay, let's say we are talking about healthcare. Now, next we may want that, we want to prepare some presentation for some technology related topic. So those two are not relevant. So what we can do, we can open a new session or we can clear the history of the existing session and then start fresh. Okay, so that will have unnecessary context and history bias uh, avoided by the LLM. Use summarization for long content. Okay, so again, this is one technique. If you have a 10-page PDF, or 1-page PDF with lot of different context, so if you summary paragraph to paragraph and give it as a query, it will definitely help to reduce your cost and time and tokens. Avoid repeated system instruction, obviously, self-explanatory. Store important information externally. This is many places for the security reason, or for company policies and all. So this is required. So you have to store it externally. Use short identifiers instead of full data. Okay, so we can have short identifiers. So what will happen, so when we raise a query to your AI model, we'll say, okay, A equal to this, B equal to this. So uh, A means, for example, A means what is the capital of France, B means this, and C means this. Okay, so now next question, if you raise it to the particular AI model, you will say, okay, refer A, and this is my question, part 2, part 3, part 4. Okay, if I take this, okay, so refer this question, I'll say, okay, A, for example, in question, in bracket, I'll say question 1. Okay, and then I will say, uh, in Q1, replace France by India. Okay, so if you see, I'm not asking one, two, three, four, five, six words. I'm not saying, okay, what is the capital of India. I'm just saying, okay, replace France by India in Q1. Okay, so if it is a large prompt, okay, and then I just want to replace one thing, so I can refer it by Q1 or some variable or whatever, and that will reduce the cost for the subsequent question or subsequent queries. Okay, trim unnecessary output before sending to next prompt. Okay, so probably some special character, comma, dash, hyphen, quote, into inverted double quote, single quote, so that unnecessary, or some spaces, blank spaces, whatever, that we can trim to increase, to lower the cost of cost and time. Like leverage caching of responses. So yes, caching is also important. As I said, one example for the Christmas sale. So we can do a lot of caching, and then reply or answer the question from the caching instead of the actual, every time running the query and consuming power and those things. So that is going to help. So cache frequently asked questions for a particular topic, particular item. Okay, cache embeddings for documents, cache intermediate processing result, static system prompts, use cache hash based caching, and cache prompt response pair. Okay, right, so same thing here. So let's see here. So cache frequently asked questions. Okay, what is API testing? So this can be a question, or there are top 10 questions related to API testing. So daily this kind of question will be asked to your AI model, like let's say ChatGPT. So every day they are asking, okay, people are asking, what is API testing, what is Selenium, and what is Java script, and those things. So those kind of questions you can cache it and then answer it from the cache. Okay, cache embedding for documents. So instead of regenerating embeddings every time, okay, reuse the stored embedding. Okay, increase to save cost and money and tokens. Cache intermediate processing result. Okay, so step 1, document summarized. So store the summary instead of reopening it. Okay, uh, so yes, so as I said, in attachment example, every time don't want to attach the document, which will increase the time and cost and tokens. Since I just do caching, and then next time you don't open the document. Cache static system prompts. Okay, instead of sending your system prompt every time, reuse the stored reference. Let's say there is some fixed data, or always people are asking, let's say for example, who is the president of United States. So once you store it until the president changes, it will be the same, right? So then you can use it from uh, stored references. Hash based caching. Okay, so it is easy to look up, just search for the hash ID or whatever, and then you can retrieve the content. It is easy for programmatical purpose and so on. Cache prompt response pairs. Okay, so not only cache, not only the prompt, but prompt and response, both you cache it and then you reuse it. Okay, right. Control output length. Okay, so fine, so you have given a query to LLM, optimized query. LLM has processed it and then you got the output. Now output length can also be controlled. Okay, and that will again save your tokens, then time and cost. Okay. You explicitly define the output size. Okay, so let's say I want the output in 3 bullet points. That's it. Okay, so instead of having random number of bullet points, you say 3 bullet points in the response. So that is going to exactly calculate and save your tokens. If you don't have open end, if you put it like open ended question, okay, give me the output in bullet formats, but then bullet points, but then how many bullet points, what is the length of each bullet point. So that instead of avoiding instead of open ended questions, we can use the specific output size. Use word or token limits. Okay, so again we can apply some limit for every query what we raise. Okay, avoid open-ended words. Okay, same thing about open-ended thing. Use stop conditions. Okay, so authentication with an example. Explain authentication with one example. Okay, so specific question and specific number I'm giving, so it will give you the exact output. Use stop conditions. Okay, so generate 5 test cases only. Stop after test case 5. Okay, right. So give me 5 reasons to apply for a particular course, and then stop that after that. Okay, so do not you have to say that, okay, do not generate any other information and so on, because what will happen, LLM may over engineer the question and the answer, and after giving the required 5 test cases, it will also start explaining the test cases, and maybe it will ask some question. Okay, do you want to design critical test cases or high priority test cases, something like this. So we want to say, okay, only these 5 test cases and then stop. Okay, define a structured format. Okay, as I said, the output should be in JSON, XML, CSV, whatever. So we are defining it in a specific format. Okay, right. Okay, so these are the I would say probably some 7 to 8 categories, and each category have 5 ways. So at least let's say 30-35 ways to save tokens, which will save your time and cost. Okay, so I hope you like the content of this video. If you like this channel, please like and subscribe to my YouTube channel. Thank you.